Hello, Victor. Welcome to the webinar.
Hi, Aidan. Really good to see you. How are you doing?
Thank you. I'm very good, thank you. I'm very, very good. I've got a quick introduction. I'm going to introduce everybody to myself and Axoft, and then I believe you've got a presentation for us.
Yep.
Okay, nice one. And then some questions that we've gathered up from some of our clients that hopefully you can help us out with.
Of course, yeah.
Thank you. Okay, so hi everybody. I'm Aidan Hubbard. I'm the Chief Commercial Officer here at Axoft Limited, and we are the local distributors for Airly products here in the UK. Me personally, I've been working in this industry for well over a decade now, and I've seen some major changes in instrumentation used for air quality monitoring over those years. And Victor, I remember walking around carrying these huge metal boxes with really sharp corners digging into my ribs as I was trying to install them onto construction sites. These things were, the sort of systems I'm talking about, right? But, these were super heavy, super high cost. And, I can't help but feel like it just created a huge friction between instrumentation suppliers and manufacturers. And the people that were doing the monitoring, I felt like it was tough to get them to monitor at more locations, and then sometimes to do monitoring at all. And then I saw a major change with instrumentation with the introduction of these low-cost sensors with MCERTS, and they were coming into the market. And these tiny little systems that you're going to talk to us a bit about later, they could fit into my pocket and pretty much are doing the same thing. So we can install them for a fraction of the cost and a fraction of the time. And we felt that the big difference that came from that is that people weren't just monitoring, but they were monitoring more. So we had better data, higher quality data, and more data at more points for, I guess, similar costs than what we had before. So today, we're very lucky to have Victor with us today. He's the co-founder and CEO of Airly, and who's at the iron face of some of the challenges that have come along with the low-cost sensors. So I've got some challenging questions for you later, Victor. Hopefully you'll be ready for some of those to help clear up some of those questions that have been generated. And I'll hand over to you now for a quick presentation, and we'll meet back up again for a Q&A.
Sure. Thank you a lot, Aidan, and welcome everyone. I would like to thank you for co-hosting. And I want to have these few slides as a practical, honest conversation about what sensors can and can't do. And that will be evidence-led, not sales-led. So yeah, we can start. I think the topic of this presentation is small sensors and big impact. And I would like to start with the history of air quality monitoring. I mean, in the beginning on the previous century, like every air pollutant was measured using wet chemistry. So using like a big containers, very bulky, very expensive. And generally in the UK, there were a few stations providing daily, weekly, sometimes monthly air quality data for some specific regions. In like a 60s, 70s, in the last century, reference instruments started to appearing, and that was like a more digitized ways of measuring air pollution. So the size of the PC, the scale was going into hundreds or even more than 1,000, and resolution went from like daily or weekly to hourly, which was like a big step forward. And over the last like 10, 15 years, sensor networks started appearing on the market. And then look, the size of these sensors are like the size of your phone, and we are going about a scale of like a tens of thousands of sensors being installed across the UK, and we can go with the resolution into seconds. So I think the key message is like each generation multiplied coverage and resolution while cutting costs. And sensors, from my perspective, are a third wave. It's not a toy, not a compromise. And we are not asking sensors to replace reference stations. We are asking them to do something reference stations were never designed to do. Go everywhere and provide hyperlocal real-time data. So what sensors enable? And I think there are a few aspects looking into that. And first of all, looking at spatial granularity. on a large site, on a large construction site, you can have a single downwind reference monitor and miss what's happening near the boundary. Or you can have few early sensors giving you real-time upwind, downwind data. And this is something that Institute of Air Quality Management itself recommended exactly. Second thing is about real-time alerting, real-time data. So with our systems, you can get updates every minute and you can get real-time notifications. So for example, when the action level is exceeded, you can get these real-time notifications, and action levels generally are meaningless if you find out about it in like a daily or weekly report. So the value is about like having the value sits in having real-time notification. Again, you can install them anywhere you need. We install them on schools, hospitals, construction sites, streets. They can measure different parameters. And the big value that a lot of air quality consultants and people in air quality area sees is first, they're helping with providing a source attribution, so we can distinguish local versus regional pollution. Again, coming back to this upwind, downwind differential data, but also data from air quality sensors can really provide great input for air quality modeling. And thanks to that, we can like lower the uncertainty of some models. When it comes to our hardware, Airly is a really plug and play solution. So you can plug in, it connects. No need to put inside a SIM card, no need to set up a Wi-Fi network. We have like a built-in GSM connectivity, which is really convenient for customers. We are measuring the most important pollutants, so particulate matter, PM1, PM2.5, PM10, but also gas pollution. With a 5-minute data resolution. For some like customers, we can go even lower than that. Our sensors are waterproof and durable, and what's important, we can provide a flexible power options. So solar means you can put it exactly where you need it, not where there is a power outlet. So one person, a few minutes, no specialist training, and that's a big contrast with a reference analyzer installation, when sometimes you need to build a whole infrastructure around to be able to plug in the reference equipment. Obviously, we are MCERTS certified for PM2.5 and PM10, and I will explain in the next slide what exactly it means. So sensors, as I said, they are quite new to the market. So very often with this with this new technology, the tech is like really a few steps behind the legislation. But the UK introduced a few years ago MCERTS, which is a performance standards for indicative particulate matter monitors, and we are really proud to have that. I guess there will be some questions around that in a Q&A session, so I'm happy to answer them all. DEFRA also published a publicly available specification 2 years ago, and that's the most current UK guidance on how to deploy sensors properly. So it defines the best practice for using them well. I think these two documents, like MCERTS certification, but also PASS, they're very important on the way how air quality sensors are being introduced to the market. Obviously, in different countries, in different parts of the world, it's also a lot of things happening. So in the US, EPA published a sensor guidebook, which is providing also the guidance for users, how to use sensors, both for fence line monitoring, but also for ambient air quality monitoring in cities. And what's really interesting is a new technical specification published by European Normalization Committee for air quality sensors performance. So MCERTS is only covering particulate matter PM2.5 and PM10, but the new upcoming standard is all about particulate matter, but also gas pollution. And I think from my perspective, and I'm also like sitting on the working group 42 working on this technical specification, regulation is evolving to embrace sensors, not exclude them. So we are building ahead of where regulation is going currently with a lot of sensors. But again, all of these things that you are seeing, it's all about embracing usage of the sensors in the different like use cases. But we are seeing more and more sensors widely being accepted as a way how to measure air pollution. I think just to like manage expectations honestly, like sensors, they can be great, and sensors are excellent at qualitative work by default. And this is all about identifying pollution hotspots, comparing locations across an area, seeing as peaks by time of the day, and also detect events from transport industry. For quantitative like use cases, sensors require care and appropriate calibration. So obviously you can track concentration changes over time, you can measure efficacy of different interventions and evaluate actions that you are taking. But again, for that, you need to have sensors being calibrated. And when it comes to like a usage of sensors for the construction site, I think these are very important things. So first of all, sites change daily. So demolition phase, earthworks, fit out, all have different dust profiles. A fixed monitoring point from day one may be in the wrong place by week 3. So that's why like having sensors and having a few of them, it's really important to capturing what's happening on the site. Second thing is about providing real-time alerts. I've mentioned it already. By using an early data platform or SFANet, you can easily provide real-time notifications and alerts site managers in the workflow when the PM10 is exceeded. And the last thing, like our sensors are really built for sites. So solar powered, wireless, weatherproof. And I think this is really important. So this isn't just about good practice. It's about being able to demonstrate to the environmental agency and local authorities that you are managing dust properly. And that's the end of my short presentation. I would like to thank you for your attention. Again, I'm open to hear your questions, Aidan. And we'd rather to have this conversation in the open than leave doubts unanswered. So thank you a lot, and I'm happy to answer all of your questions.
Thank you, Wiktor. Great presentation. Really appreciate it. Covered lots of areas. As I said earlier, we've got some questions. We've gone to some of our clients, and we've been asking contractors, monitoring contractors, and air quality consultants some of their main concerns that they have with sensors in general. And so I've got about 5 questions. I'll start with the top. And this one's from me, actually. One of the main reasons that we wanted to try and get you onto this call was because of the statement that was recently made by the IAQM, and I believe confusion that's been caused because of that statement into our market. All of that good work that we've done with building lots of extra sensors, I don't want that to go backwards. So they seem to have a concern that low-cost sensors can't measure accurately at high levels of PM10, and I'd love to know your thoughts on this.
Yeah, I think the IAQM concern is legitimate as a statement, and I saw like some sensors, especially which are having issues with high humidity, or some using some like a machine learning algorithms and techniques to predict. So some of them, they genuinely do underreport at high concentrations, and that can be a real problem for construction monitoring. Our position is clear, like our sensors do measure above the action level, and we have a lot of examples. We have years of UK field data from hundreds of sensors collocated in the different areas of the world, and we can show exceedances above the threshold across like many construction sites. So the IAQM is right to push the industry on evidence, and our response to that is here's ours. Not all sensors are the same, and that's the conversation we should be having.
Okay, yeah, good. Actually, that leads me to my next question. I'll push this question up a bit higher because of that statement you just made. Because for me, a few years ago, all we were ever asked for here at Axoft was an air quality monitor with an MCERTS stamp. And it seemed that that's all anyone ever cared about. We were asked one question: can it measure PM10 and PM2.5 simultaneously? And does it have MCERTS? And the rest didn't matter, right? It was a bit of a boring conversation. And then I've learned a lot from you since I've met you, and you say that not all MCERT certifications are the same. I wondered if you had any words for decision makers, people that are buying these sensors, and what they should be looking for around MCERTS.
Yeah, that's fantastic question, and I think that there are like three things to check before you trust any MCERT certificate. So first, I think is, did the sensor actually pass for PM10? So not all MCERT certified sensors like are certified for PM10. So you need to check the specific scope of the certificate. So I really recommend just downloading a certificate and just looking at it. So not just the words MCERT certified appearing on the brochure, but just looking into the certificate, what's inside, and whether the sensor is PM10 certified for MCERTS. I think second thing is looking at the relative expanded uncertainty. So that's the one of the requirements for MCERTS. So the pass threshold is 50%, like against the limit value for PM2.5 and PM10. But there is a huge range between suppliers. Some scrape through close to that limit, so they're having like 49%, and early achieve like 21% for PM10 and 24% for PM2.5. And that's not just passing, it's a passing with significant margin. So some others we have seen were like, again, like 40% plus. And I think that difference is material when you are measuring against an action level. I think the third point that I would like to raise is find out whether some additional site-specific correction algorithms are required and whether they are actually being applied to your deployment. Some sensors, and that's written in the certificate, according to MCERTS, need local recalibration or adaptive correction to perform within a spec. So if those corrections aren't applied in the field, the certified performance isn't what you're getting. So I think these three things are very, very important. So again, I strongly recommend looking at the certificate, not only looking at the brochure and the stamp that it has MCERT.
Okay, good. Actually, great comment there, because it brings me into my next question regarding calibration, because I guess MCERTS and calibration are tied together in a way. And I was hoping that you would be able to share some of Airly's secrets regarding your own calibration processes, if possible.
Yeah, so our calibration follows MCERTS requirements. So we, before like any shipment, we have like a 2-week collocation against the certified reference analyzer. Specifically, we use GRIM ADM, which meets the fixed measurements criteria under European Union directive. That's a reference instrument. It's the same standard used for ambient monitoring networks. So we are just collocating these sensors for 2 weeks time, and from that collocation we derive a slope correction factor. It's fully documented, no black box algorithms on top of it, and that's the one thing that IAQM also mentioned in their statement. So we should avoid like a black box machine learning AI algorithms. The stuff that we are providing alongside the certificate is fully documented calibration process which we are undergoing. On recalibration frequency, I think it's also very important. So we also follow MCERTS guidance on maintenance intervals. And as a general principle, sensors in heavy use construction environments should be reviewed. And any sensor that has taken a knock or shows unusual readings should be checked, and this is what we are also doing. And I think this is really important to have in mind that it's like sensors, they have some lifespan, and especially in some harsh environment, it's worth going through the recalibration process and make sure that the sensors are having a good quality.
Okay. So this next question is a question from the Axoff team, a bit of a fun one for you. So we're wondering why people don't just use big reference grade systems for any type of air quality monitoring. And with the answer to this one, you're not allowed to use the excuse of size. Right, so let's ignore that. We've covered that. You've heard some of my examples. So yeah, why isn't everyone just using reference sensors?
Yeah, I think the price is also like a really important factor there. But from my perspective, maybe let's like stop for a second and explain what are the differences, because the performance gap is smaller than most people assume. For particulate matter, reference instruments are certified to 25% expanded uncertainty. Indicative sensors like ours are certified to 50%. So as I mentioned before, like early's actual certified like accuracy is like 21%, 24%. So we are technically performing within the reference grade threshold on paper, even though we are classified as indicative. I think it's very important, this like difference, like 25% for indicative measurements, 50% for reference instruments. And that side, there are like differences in measurement approach. Reference instruments typically use gravimetric methods. So physically, they are collecting particles on a filter and weighting them. That's a gold standard for mass concentration accuracy. And I think the key word here is fit for purpose. So reference instruments are designed to produce regulatory grade ambient monitoring data. They require a specialist installation, regular servicing, mains power, climate control enclosures, ongoing quality assurance, blah, blah, blah. But for construction site, dust management, where you need real-time alerts, rapid deployment, and multi-point coverage, they're the wrong tool for the job. Not because they are worse, because they are better in many cases, but because they weren't designed for that use case. And that's partly about the size. I know that I wasn't allowed to use that, but that's partly about the size too, right?
Thanks, Victor. So another issue that I take issue with this wording of low cost sensor, right? Because these sensors, like any system out there which has the label of low cost sensor, you know, they cost more than a bag of chips, right? So maybe you can tell us more about what's inside of the take your own sensors, for example. What's inside of the Airly sensors, and also as a second part of that question, could you try and address the way that an Airly sensor may deal with condensation?
Yeah, so for the sensor technology, let's start with that one. For particulate matter, we use laser light scattering. So that's the same like measurement principle as reference class optical analyzers, like GRIM ADM we calibrate against. So this is the same like a measuring principle. A fan draws air through a measurement chamber, a laser illuminates the particles, and a photodiode measures the scattered light to determine the particle size, distribution, and count. And I think for particulate matter, that's the data that we are using. And the difference from reference instruments like isn't the physics itself and the measurement principle. It's the precision of the optics, so like a laser and photodiode, the volume of air sampled, and the level of environmental control. And our sensors are engineered to get as close as possible to reference grade in a robust field deployable package. But I think it's important not to over-engineer your solution. And I see like some of our competitors and other manufacturers on the market, they add large external heated inlet tubes and temperature controlled enclosures. Like these can work, but they also add complexity, potential failure point, and obviously cost. So there is a reason like sensors with those features often cost like more than 10,000 like pounds. And our view is that over engineering can actually reduce robustness in field conditions, because more components means more things can fail when a device is deployed on a windy construction site for like a year or two. And we like by the design, we optimize for simplicity, but also reliability and accuracy alongside performance. And the fact that we achieve better results and better humidity stability without a full heated inlet systems tell you something about where the engineering effort has gone. And that's like moving me to your second question about like managing like humidity and condensation. So condensation is a real issue that some sensors handle very, very badly. If humidity causes water droplets in the measurement chamber, you get massive PM10 overestimation, false alarms, or like even worse, like missed real events masked by noisy data. And our approach is active thermal conditioning. So our sensors heat the sample air by a few degrees above ambient before it reaches the measurement optics. That keeps us reliably above the dew point across the full operating range. So we have also a lot of collocation study done by means like Inspectorate of Environmental Protection in Poland. And that was a confirmation, like independent confirmation, that there was no statistically significant humidity influence on our readings across the whole relative humidity range, even talking about like 90% plus. So this is something that we did. And again, not over engineering your device, just to keep the cost, effectiveness, and not like cutting corners on the underlying physics, but about the manufacturing the device in a way that it's like viable and you can scale with the product.
Thank you, Wiktor. I mean, that was the last question that we had from some of the questions that we had developed. I really appreciate your answers on that. I've personally learned loads from that already. And I'm going to put you on the spot for one final question, and it's not really a question. I was hoping that maybe you could give some golden advice, maybe summarize everything we've spoken about today in a few sentences that will help people maybe understand these low-cost sensors a bit better and help them make a decision for the future.
I think look for the quality. That's no-brainer, and check like MCERTS certificates. But also, like, do not expect reference analyzer at the fraction of cost and the fraction of size that you're going to. This is different technique. I mean, different technique. Like, these are different type of devices. They are designed to like work in the different environments, including construction sites, but they are not going to replace the reference instruments. They can be in some ways better. In some ways, they can be worse. That's also true. So my first advice is do not like think about small sensors as a reference analyzers, because this is not reference analyzer. And the second thing, even within like a small sensors, look for the best quality and check MCERTS certificate without making the decision about your solution.